Let us look at proposition number 10 of book 8 of Euclid's Elements. The proposition says, if numbers fall between two numbers and a unit in continued proportion, then however many numbers fall between each of them and a unit in continued proportion, so many also fall between the numbers themselves in continued proportion. What the proposition is saying is that given two numbers A and B, if there are two numbers between the unit and A and between the unit and B in continued proportion, the same number of numbers will fall between A and B in continued proportion. So let's see how we can prove this. We are given two numbers A and B, C be the unit. Let D and E fall between C and A in continued proportion. Let F and G fall between C and B in continued proportion. So now what we are going to do is, we are going to actually build H, K and L, because everything else we have. We have C, we have D, we have F, we have E, we have G, we have AB. So H, K, L we have to build. So let H is equal to D times F and let K is equal to D times H and let L is equal to F times H. So we have the entire thing in place. Now C is to D is equal to D is to E. C is to D is equal to D is to E. Why? Because remember, they are in continued proportion, okay, which means unit C measures the number D the same number of times as D measures E. Unit C measures the number D. Unit C measures the number D according to the units in D. So which means D also measures E according to the units in D. So what this statement means is that E is equal to D times D. Now let's take the next part. C is to D is equal to E is to A. Why? Because they are in continued proportion. Unit C measures D the same number of times as E measures A. C measures D the same number of times E measures A. Unit C measures the number D according to the units in D. So therefore, E also measures A according to the units in D, which means we can say A is equal to D times E. Similarly, we can show that G is equal to F times F, D is equal to F times G. So, which means D is to F is equal to E is to H. From where did this come? D measures E, because E is D square. So, E is equal to D times D. So, D measures E and F measures H, because H is equal to D times F. So F measures H, same number of times. So D times D is E, D times F is H. So that means D and F both measure E and H the same number of times. So we can write this as a proportion. So you have to really be focused on this. Now, similarly, D is to F is equal to H is to G. D measures H. D measures H. Why? Because H is equal to D times F. Similarly, F measures G. Why? Because G is equal to F times F. So we can write it as a proportion. Now, here if you notice, D is to F is there in the left hand side in both of these. So we can write it as E is to H is equal to H is to G. So E is to H is equal to H is to G. That means these three numbers are in continued proportion. Now, E is to H is equal to A is to K. Why? Because E measures A. E measures A. Why? Because A is equal to D times E. A is equal to D times E. H measures K. H measures K because K is equal to H times E. So we can write it as a proportion. E is to H is equal to A is to K. Now again, E is to H is equal to D is to F. First we compared these two and these two. Now we are comparing these two to these two. So again, E is equal to D times D. So E measures D and H is equal to D times F. D measures E and F measures H. So you have to be careful. Okay. So we have this. Since E is to H is there in both the sides, on the left hand side in both, we can write it as A is to K is equal to D is to. Now let's take K and L. So D is to F is equal to K is to L. D is to F is equal to K is to L. How? Again, you have to follow the chain. K is equal to E times H and L is equal to F times H. So if you follow the chain, you will end up with D is to F is equal to K is to L. A is to K is equal to K is to L. A is to K is equal to K is to L. Now, how did this come? Since A is to K and K is to L both are equal to D is to F. Now, H is to G is equal to L is to B. Again, H measures L because L is equal to F times H and G measures B. Why? Because B is equal to F times G, right? So, which means H is to G is equal to L is to D is to F is equal to H is to G. We have already seen this in the first column. H is to G is equal to L is to B. How? Because H measures L because L is equal to what? L is equal to H times G. G measures B. Why? Because B is equal to F times G. Basically, it measures the same number of times. So we can write it as a proportion. So here if you notice H is to G, H is to G is there. So we can combine them and write it as D is to F is equal to L is to. So look at this. A is to K is equal to D is to F is equal to D is to F. K is to L is also equal to D is to F. L is to B is also equal to D is to F. Since all of them are equal to D is to F, we can write it as A is to K is equal to K is to L is equal to L is to B. A is to K is equal to K is to L is equal to L is to B. That means these four numbers are in continued proportion. The multitude of numbers between C and A is equal to the multitude between A and B. So here we have two numbers between C and A, and we have two numbers between A and B. Similarly, the multitude of numbers between C and B is equal to the multitude of numbers between A and B, which is what we had to prove. That is proposition number 10 of book 8 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions with proper references to the previous proposition that we are using. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.